Hi, why do we ever use AC to power homes instead of DC? Haven't I showed you that AC is typically more dangerous than DC? Can we run everything on DC? Yes. In fact, pretty much every device at home has to rectify AC into DC first before it can use it. So why? Why am I angry? The reason is elementary. Once there was a fight between a guy named Nikola Tesla being AC and Thomas Edison being DC, and Tesla won the contract for his employer Westinghouse Company to provide power with AC. No matter how hard Thomas Edison tried to expose the dangerous nature of AC by electrocuting dogs and elephants in public. Wow. Now I remember why I'm angry. This Edison guy was an animal. He even invented the electric chair to execute with AC. Not because it was a cleaner or better way to execute, because he wanted to deface AC by forever associating it with death. Nikola Tesla very rightfully won this battle. Yes, AC can be more dangerous than the same level DC, but a higher level DC can be as dangerous, if not more. And just because something is dangerous, we don't stop using them. Like for example, if you live in a high-rise, you're not in a constant risk of jumping off the window. But is there an advantage of using AC? I mean, back then all they wanted was light using incandescent lights, and those don't care about AC or DC. Here I'm running a regular light bulb on AC as usual, and here I killed it. Don't short. Anyways, with this I'm converting the AC into DC using it's a single diode, but it will do. And if I measure the voltage at the output, holy the capacitor, piece of shit. Anyways, I'm reading around 170 volt DC, and although it's still quite dangerous, I can still touch it, and it's not as remotely as painful as touching the 120 volt AC, and the light bulb runs on it just fine, and it's even a little bit brighter because it's 170 volt continuous. Beside the lights, the electric motors were becoming more popular in home appliances like meat grinders or fans and such. But even those could be made into brushless AC or brushed DC, for example. Of course, a brushless AC motor like this one that I took from an old microwave oven can last much longer than a brush. Loose wires, avoid them. Anyways, brushes in DC brush motors wear out eventually, and that's why AC motors can last longer. But beside that fact, there doesn't seem to be much preference between AC and DC. But the real advantage of AC is not at home, it's before electricity even gets to home, in transmission lines. And that's why Edison's DC power distribution system eventually died away. Here I made a transmission line using thin wires, and using my supply I'll try to place 10 volts across my 1 ohm load for 10 amps of current, and I'm measuring the voltage across my load. Let's try it. See, the voltage is like 7.5. And you see my transmission line is starting to smoke and heat up, and the voltage continues to drop. See, the line resistance is so much that the voltage across the load doesn't even get to 10 volts. It's at 7 volts for 7 amps through the load. And because of the high resistance, it's heating up so much. Similarly, because Edison was passing low voltage across the transmission lines, a ton of current was passing through the lines. And there is a limitation to how thick you can make the wires before they break under their own weight or become too expensive. Huge currents through the resistance of the wire would result in large voltage drops over longer distances. And that's why Edison's system could only transmit power to around a mile or two from the power source. Otherwise, the power loss would be so much over the lines that would cause huge inefficiency. Of course, Edison was aware of his shitty system, so he decided to let one of his genius employees to take care of the problem, who was our beloved Nikola Tesla. He was working for Edison at the time. According to Tesla, Edison promised him $50,000, which was a lot of money back then, if Tesla was able to make great improvements to Edison's DC system, which Tesla did in a few months. And when he went to Edison to ask for the money, he said, I was joking, obviously you're not aware of our American humor. To which Tesla said, F you, I quit. Later, Tesla came up with his genius system and developed it for Westinghouse Company. What he did was to transmit power much smarter. He used AC so he could change the voltage level using transformers. Here I'll use my auto transformer to generate 10 volt AC, which would result in 10 amp AC through my 1 ohm load. But before I send it through the transmission line, first I'll step the voltage up using my microwave transformer. And then I would step the voltage down after the line if I had a transformer. Well, guess I can borrow the one from our microwave. They're using tamper-proof screws to stop me. What they don't know is that nothing can stop me. They're just postponing the inevitable. There we are. I'll just take a picture of the wiring before I pull it out. I don't want to blow it up later. There we are. Okay, now we have both transformers connected. Let's do some voltage measurements before I connect the load. At the input, we have close to 10 volts, so that's good. On the transmission line, we get around 190, 200 volts. And at the output, again, we have close to 10 volts, so that's pretty good. Now let's connect the load. Okay, and the voltage across the load is 1.6 volts. That's garbage. What happened? The transmission line voltage 118 volts. Everything dropped. This is worse than the DC system. What's going on, Tesla? Let's measure the transformer's secondary winding resistance. It's around 100 ohms. No wonder. There's too much drop over the large resistance of the secondary. So these transformers are not made for this purpose. That was a bad example. Doesn't matter. I'm gonna transmit power no matter what. 2 volts, 3 volts, 4, 5, 6, 7, 8, 9, and 10 volts across the load. We did it! And our transmission line is not burning, so that's always a plus. Nothing is exploding. What is the transmission line voltage now? $820 volts! Well, anyways, although this is a pretty bad example, you can see that I'm transmitting more power than the DC system, but my transmission lines are not burning. So that's sort of a success. See, in this system, I can transmit a lot of power, in this case around 100 watts, without having to thicken the transmission line wires. And if the transformers were better, the efficiency would be higher too. In fact, in this system, the higher you convert the voltage to, the easier it is to transmit power over greater distances, with some limitations, of course. That's why in real life, they convert it to 10 kilovolts or 100 kilovolts. Why? Because in transformers, the input and output power is ideally the same, although not really, because there's always some power loss, as you saw. And power is voltage times current. So for example, if I increase the voltage by 20 times in order to have the same power, the current has to drop by 20 times at the output of the transformer and over the transmission lines. And because the power through a resistor is equal to resistance times current squared, the power would be 400 times less wasted on wires. And with high voltage comes great responsibility. The transmission lines have to be placed far enough so no arcing happens. There is no easy way to do the same thing with Edison's stupid DC system. In order to change the voltage, you would have to convert DC to AC, increase the voltage, and then convert the AC back to DC, and lose a lot of power in the process. Edison still couldn't see this. All he saw was that his company was losing the contract of his life to power the world. So all he did was to grab the fact that Tesla's system was running on super high voltage, like 10 kilovolt or 100 kilovolt, and say that it's super dangerous to people by electrocuting animals with 10 kilovolt in public. Thomas Edison. He contributed a lot to science and technology, but he was also an asshole businessman, and that bit him in the lower back area. The moral of the story, don't be an asshole.
Giveaway time!
You know, Circuit Specialists has been quite nice to me, providing all my basic tools and components and everything. And I really hope you find what you need in their website too. And I'm quite happy with the multimeter they sent me, which is an LCR meter. It measures inductance, capacitance, resistance, voltage, current, and a bunch of more stuff. So thanks to Circuit Specialists, I'm gonna give away 5 of these to my patrons at patreon.com and you, the viewers. Also, if you want to start electronics, you would need a lab power supply, and I'll give away 4 of those too. As usual, my patrons are automatically in the draw. For everyone else, please follow the link to the Google form in video description and let me know which one you need and I'll draw your name. And that's it. Unibrow out.